Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on combinations, permutations, and fundamental counting principle. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. And this is part 3 of the series. And we are picking up in the middle of an example, so you may need to watch part 2 of the series to understand where we're at. But it was going to be too long and I didn't want to interrupt it in the middle of a problem. And so I am picking up with question 2, which is how many ways are there to select a committee of 2 people? And in this case, remember we're dealing again with 3 lists, and we have our 3 lists here, and we know the type of things that we have for these 3 lists, but we need to determine, and this is the beginning of determining which type of list each would be. So, would selecting 2 of the same people work for a committee? That's usually the first question I ask myself. Can one person represent 2 people on that committee? If this group needed to elect 2 people to a committee, would sending may and then may again make sense? No. So we cannot allow those repetitions. And since repetitions are in list 3, that eliminates list 3 and thus the fundamental counting principle as an option. Next, let's think about order. Would a committee of may and kin be different than kin and may, or sending these 2 people to join a committee? No, because both would still be on the committee, and there's no difference in being listed first or being told first that you're going to be on the committee and being told second that you're going to be on the committee. They're equally on this committee. Therefore, order is not important, and that eliminates list 2 where order is important, and thus leaves us list 1 where order is not important and repetitions are not allowed. And this is the list we want. Since this list is a combination, that would be 4C2 or 6 ways to select a committee of 2 people. No repeats. Order is not important. Question 3. How many ways are there to select a president and a vice president? Again, we're selecting 2 from the list of 4 names. The first thing I ask myself is, can we have repetitions? Are repetitions allowed? Could may be both president and vice president? No. So, list 3 and fundamental counting is not going to be my list. In list 2, order is important. In list 3, order is not important. So the next question I need to ask, is the order important for picking these jobs? Would a selection be different if we picked May for president and Ken for vice president? Would that be different than picking Ken for president and May for vice president? Yes, that would be a different selection. They would have different titles, different job duties, and it would be a different selection. So order is important, and therefore we have list 2 as our answer. And since list 2 is a permutation, we have 4 P2 or 12 ways to select a president and a vice president. Notice that the job title gives an importance to the order. How many ways are there to select one representative to go to a meeting in March and one representative to go to a meeting in August? Again, the first thing I always ask in a counting problem is whether repetition is allowed. And in this case, May could go both to the meeting in August and to the one in March. Therefore, the only list that takes into account repetition is list number 3. Since that's the only place where I can have repetitions, I don't even need to ask whether order is important, because and I know that I have the fundamental counting principle, which is 4 times 4, 4 ways to select the first person and 4 ways to select the second person, which would give me 16 total ways. Question 5. Can we repeat? Oh, excuse me, I'm supposed to read the question first. How many ways are there to select 2 people to go to the same management training class? So this time we want to send 2 people to a management training class. Can we repeat selections? In other words, can the same person go to the same management training class, in this case implying at the same time? And the answer to that is no. We have to select different people to send 2 people to this class. So since we can't have repetitions, list 3 and the fundamental counting principle is out. Next, decide about order. Does it matter if you are notified first or second about this training? Is there any job title or difference in the way that you're selected to go to this class? No. Each person selected gets the same training at the same time. Therefore, order is not important, and since order is not important and repetitions are not allowed, we have a combination, which is list 1. 4C2, 4 combinations of 2, or 6. Question number 6. In a school play, how many ways are there to select one person to play the policeman and another to play the criminal? Can the same person play both parts? In other words, can we allow repeats? Since that answer is no, we cannot have repeats because the same person cannot play both parts. That eliminates list 3. That eliminates the fundamental counting. This tells us, since we're not using fundamental counting, that we need to think about order. Is there a discernible difference between the choices? Yes, that doesn't mean that you have to have a preference for one choice. It just means, is there a distinguishability between the choices? You can tell a difference in the jobs in the school play. They'll have different costumes, different words to say in the play, and a different outcome in the play. If there are what I call, and I put this in quotes, job titles, then order is important. If order is important, then we have a permutation, and that is list 2. And since we have a list 2 here, that is 4P2 or 12. And finally, we're getting to question number 7. How many ways are there to select 2 people to wait on tables at a church breakfast? Again, start with, can we have repeat selections? No, if you pick the same person, then you do not have two people to wait on the tables at breakfast. This tells us we're not using fundamental counting and list 3. The next step, as always, is to look at order. Is order important? Can we distinguish between the jobs or selections by order? If we pick Bob then Lee to wait tables, is it different than picking Lee and then Bob to wait the tables? No. So order is not important. So we have a combination as illustrated by list number 1. And that gives us 4 combinations of 2, since list 1 is a combination, and our answer is 6. Here are a couple of questions for you to try. Remember to always pause the screen and do not try to do the problems in the little bit of time that I give you. And I will stop the third video here after we've introduced the permutations and combinations. Please watch the next video where we will cover some different examples on this. And thank you for watching part 3 of this series. If you need more help and are a Walter State student, please come by the Math Lab at MBSS 222.